Okay, 8.4. So basically 8.3, but just day 2 of it. So same topic, just like longer, more complicated problems. So number 1 through 3 asks me to expand the following logarithmic functions. So in other words, expand tells me I have a singular log, I need to expand it into multiple logs. So let's see. To do that, I need to figure out all of the components of my argument. So I need to break this up into as many different parts as I can. So let's see. I don't know why that keeps sliding. The first component that I see is a squared, and then I see b cubed, and then I see c to the power of 4. So that tells me there are 3 components to my argument. I'm going to have 3 separate logs. I'm going to have log base 3 of a squared. I'm going to have log base 3 of b cubed. And I'm going to have log base 3 of c to the power of 4. All right, now as for the operations between those logs, that is where I'm going to look at what's happening between the components. So the a squared and the b cubed are being multiplied, so their logs are going to become added. And then we're divided by c to the power of 4, so that the log base 3 of c to the power of 4 is getting subtracted. Awesome. So rule 2 and 3, done. Now rule 1, I need to check for any exponents that need to rearrange into coefficients. So like this power of 2 needs to rearrange into the coefficient position, and likewise here and likewise here. So that's going to give me 2 log base 3 of a plus 3 log base 3 of b minus 4 log base 3 of c. And all of these logs have variables, so none of them can be simplified any further. We are done. Okay, I'm going to let you do number 3. It's really, really similar. I'm going to look at number 2, though. Okay, so there's a really common mistake that happens on number 2. We're going to get to in a minute. But the first thing that I see is that this whole big argument has its own power of 2. So I think a good first step would be to apply that power of 2 to the argument and then expand what we end up with. So here's what I mean. It's going to become natural log of, okay, let's see. Let me erase this. Okay, natural log of, okay, well, 5 squared, that's 25. And then each of these powers is going to get multiplied by 2. So 2 times 1/2 is 1, so x power of 1, or just x. Then this is going to become y squared, y squared, and this is going to become z to the power of 6. Okay, so taking care of that power of 2, now let's expand what we have here, this argument. Okay, the common mistake that I see all the time, I'm sure your teachers would agree with me, is when people try to break up their argument into its components, a lot of people group the 25 and the x together as one component. But that's not technically true. Like we could do that, but we wouldn't be fully expanded if we did that. Because in the same way that there's multiplication happening between the x and the y, and between the y squared and the z to the power of 6, there's also multiplication happening between the 25 and the x. So that means that 25 is its own component. That's going to get its own log. And x is its own component. It's going to get its own log. So 25 and the x, we're looking at them as separate. Then I've got y squared, and then I've got z to the power of 6. So I've got 4 different logs. So I'm going to have natural log of 25, natural log of x, natural log of y squared, natural log of z power of 6. Okay, now again, I'm going to do operations. All of these are being multiplied. There's no division at all, so they're all being added together. And then I'm going to check for any exponents, which I do see here and here. So I'm going to move those. So we get natural log of 25 plus natural log of x plus 2 natural log of y plus 6 natural log of, and then we're done. Okay, cool. Let's see. I will look at, let's say, I'll do 4. Okay. Express as a single logarithm. So in other words, condense. Take all of these logs and make it into one big log. All right, let's look. So I'm going to look for rule 1 first this time. So I'm looking for any coefficients that need to become exponents. And I see one here. I see one here. Interesting. And I see one here. So this is going to become log base b of x squared plus log base b of x plus 2 all to the power of 1/3. And then minus log base b of x minus 3 all to the power of 4. Okay, now for rule 2 and 3, I'm going to make this all one big log. Log base b. And I see that some of these are getting added, some of these are getting subtracted, so I'm going to set up a fraction. And I've got x squared up top. Okay, it's being added by log base b of x plus 2 to the power 1/3, which means x squared is getting multiplied by this right here. So x plus 2 power 1/3. Okay, and then it's getting subtracted by, log base b of x minus 3 to the power 4, which means that this is getting divided by x minus 3 to the power of 4. So remember, what's in charge is whether it's being added or whether it's being subtracted. If it gets added, the arguments multiply. If it's getting subtracted, the arguments divide. No, not yet. Cool. And then we would be done. You can just leave it like that. Okay, let's see. You can do 5 and 6. Solve each equation. Okay, let me pick which ones to do here. I'm going to do 8. I'll do 9. Okay, so solve, meaning I have to get x by itself. I'd figure out x equals what? What number? Okay, so on the left-hand side, I have one single log. Awesome. Can't like simplify any further than that. However, on the right-hand side, I can simplify that, and I need to. So I've got natural log of x plus 3 equals natural log of, and then I've got 8 and I've got 2. The logs are subtracting, which means that I'm taking the 8 and dividing it by the 2. So, well, we know 8 divided by 2 is 4, so I'll just put 4 here. So now, I'm looking at my equation. It says natural log of x plus 3 equals natural log of 4. Well, that means in order to make this true, in order to make these sides match up, this x plus 3 has to equal 4. So my ln is irrelevant. Like those parts already match. I need the arguments to match as well. So I'm just going to say x plus 3 needs to equal 4. Well, from here, easy peasy, minus 3, x is 1. Done. Cool. Okay, let's look at number 9. Similar, except this time, both sides need to get simplified. So over here, I've got natural log of, I've got 3x plus 5, and then the logs are subtracting, so their arguments are dividing, so divided by x minus 5 equals, and then over on this side, that 3 needs to come back into exponent position. So I've got natural log of 2 cubed. Well, 2 cubed is 8, so I'm going to say natural log of 8. Okay, just like on number 8, the natural log part already matches. I need for these to match. So my equation now says 3x plus 5 over x minus 5 equals 8. I need to get x by itself. So here's what we're going to do. I need to multiply both sides by the denominator of this fraction, which is x minus 5. And the reason I do that is because now this cancels out, and I'm left with 3x plus 5. And then on this side, I get 8x minus 40. Okay, now we're back in 7th grade now. Minus 3x, So I've got 5 equals 5x minus 40. So then plus 40 plus 40. 45 equals 5x. Dividing by 5 reveals that x is equal to 9. Done. Okay, I'll let you try 7 and 10. Okay, so I know that I'm not all the way through 8.4 yet, but this is kind of its own little topic. So I'm going to cut the video off here and make it easier to upload to YouTube. And then I'll film another kind of like mini video on 11 through 15. Okay. Yeah. All right, great.